Okay, I realized for some reason I wasn't recording as I was going through the answers, so I'm going to have to go backwards in time. Oh, come on. So the first part was pretty straightforward. What's meant by radioactivity? So radioactivity, that's the spontaneous disintegration of an unstable nuclei. And what's ionization? Ionization is the process by which an electron gains energy and is freed from the orbit of a nucleus, thus causing the nucleus to become positively charged. And it could just be a molecule as well. These are just book definitions. The second part here was balancing the equations. That's what I was in the middle of doing before I realized the video wasn't recording for some reason. So the first one, plutonium-239, you just have to look up the periodic table to discover that plutonium has 94 protons, and then it absorbs 2 neutrons. A neutron is 1, 0, to produce, as they say, plutonium-241, but it's still 94 protons because it's still plutonium. Then the plutonium undergoes a beta decay, and just remember beta, to balance the equation, has an E0 minus 1 in it. That's the beta particle plus energy. The minus 1 is to remind you that one of the neutrons has turned into a proton. So now we get a mercurium 241. And you can check the periodic table. It does have 95 protons. So that's the second part. The third part, at present, nuclear reactors are fission reactors. Nuclear fusion reactors are not yet viable. Outlining the difference between nuclear fission and fusion. I'm not sure how many we have to state. Nuclear fission is when 2 or more heavy nuclei, come together to form a heavier nuclei, or maybe I should say isotope actually. Heavy isotopes come together to, nuclear fission is when 2 or more light isotopes come together to form a heavier isotope, and energy is released in the process. Nuclear fusion, actually I think I have that backwards. That's nuclear fusion. Nuclear fission is when one heavy isotope is split into 2 or more light isotopes, and energy is released in that process. I wonder what Mr. Google has to say. Yeah, same thing. Okay. What else? Nuclear fission is a chain reaction process, meaning it is, or I should say, nuclear fission is a self-sustaining process with the risk of a runaway effect resulting in a meltdown. nuclear fission follows a chain reaction process. Nuclear fusion is not self-sustaining, and so requires constant energy input to maintain the process. What else do we know about it? The sun produces its energy via nuclear fusion. Power plants and weapons, nuclear power plants and weapons get their energy via nuclear fission. I'm not sure how many points to say and how much you have to contrast. Perhaps I'm missing some stuff. Perhaps I have too much. Perhaps I don't have enough. I don't know. I'd have to look at a marking scheme from a previous exam paper. What is the function of the moderator? The moderator's function is to slow down the fissile neutrons, i.e. to regulate the rate of fission taking place in the reactor. Pretty sure that's what the definition is. Oh, not moderation. Yeah. What else now? Oh, moderator, I think might be made from carbon. Or cobalt? Carbon. I think I'd go with carbon. Yeah, graphite. Yeah. Let's go with graphite then. A form of carbon. Why are nuclear fusion reactors not yet viable? The process is difficult to maintain. It is not a chain reaction process. Energy must be carefully and continuously regulated and given to the system. I think one example, e.g., is the use of lasers to heat a plasma of hydrogen and helium, thus simulating the sun's natural process. However, it is difficult to keep the gas as a uniform sphere. It's suspended in a magnetic field. Okay. I think that's all okay. So now the last part here is a bit of a calculation. It has a half-life of 432 years, 241 grams of americurium, contains that many. Why are alpha particles produced in the detector not considered a health hazard? I hope it's because it's a very low level. A low amount of alpha is produced. Not very different to the natural background radiation levels. Calculate the decay constant. The decay constant, lambda, if I remember correctly, I think it's minus log 2 over the half-life. I'm going to need to get my calculator out. Oh, come on, where are you? Okay. Let's go with 3 significant figures. 432 years. Oh, well, actually, you could use units of years. That'd be minus 1.60 times 10 to the minus 3 per year. But if you want to go with seconds, 365 days, 24 hours, 3,600. That would be minus 5.09 times 10 to the minus 11 per second. Let's check what that is. The decay constant. Decay constant for America. 5.07 times 10 to the minus 11. Yeah, I guess years, you want to say 365 days or 365.25. Is that going to be what the difference is? Let's have a look. If I put in 0.25, I get 5.08. Yeah, okay, so it's not quite 5.07, but yeah, okay. I don't know how strict they're going to be with stuff like that. So that's correct. And the activity, I assume they mean the initial activity, that will, and, oh, is it a minus or not, actually? No, actually, the minus doesn't get put in here. Let's get rid of that minus. And the activity usually has a minus in it because it's decaying. But again, some people notice they don't put the minus in. So I... Okay. Okay. I'm going to get rid of the 0.25. Okay, so I have the previous answer. And then I have to multiply it by n. Now you have to be careful. So 241 grams of americurium contains 6.0 times 10 to the 23 nuclei. But we have 0.29 times 10 to the minus 6 grams. So that means we would have to do a bit of a calculation here. Well, we definitely would have to multiply both sides by 10 to the minus 6. Divide by 241 and multiply by 0.29. Yeah, so if I divide by 241, I make that 1 gram. And then I multiply by 0.29 to make it 0.29 grams. and then I have the 10 to the minus 6. Okay, so that's the n. I just multiply by lambda. Okay, so multiply that by 6 by 10 to the power of 23 by, that's a minus 6, 10 to the power of minus 6 times 0.29 divided by 241. I'll go with 3 significant figures again. Oh, I'll just get the full number. I mean, I'll round it to the nearest whole number. Minus 36734 becquerels. Although, again, activity is a rate, the minus to indicate that's a loss. So what I'll just say is, I'll say 36734 BQ, and this is a decay, i.e. a loss. Okay. I think that's okay. This question, I think, is finished. Hopefully I didn't make any calculation. Hopefully I didn't make any calculation errors. I guess you can let me know. Thank you.